Whenever you have more than two atoms in a molecule or a polyatomic ion, there may be more than one way of connecting the atoms in the Lewis structure. Each of these unique ways is called an isomer, and each one of these would represent a different molecule. Let's take a look at a molecule that's made up of one hydrogen, one carbon, and one nitrogen. Okay, one such molecule is called hydrogen cyanide. Let's draw the Lewis structure for hydrogen cyanide. Of course, you know hydrogen is going to be a terminal atom, so let's connect the carbon and the nitrogen first. Okay, and then add the hydrogen to the carbon right here. So we have a single bond between the carbon and the hydrogen. All right, so now let's, using our strategy, we just do an octet first for each atom. So carbon already has two pairs around it, so two single bonds, so I need two more lone pairs on the carbon. And then the nitrogen has one bonding pair next to it, a single bond, so it needs three more lone pairs. Okay, let's see if we did this right. Okay, hydrogen contributes 1 to the Lewis structure. Carbon should contribute 4. It belongs to group 4A. Nitrogen, if you check your periodic table, should contribute 5. That's a total of 10 electrons. And if we count our valence electrons here, you got 2, 4, 6, 8, 10, 12, 14. So that's not quite right. Okay? Right now, we are showing 14 valence electrons. Okay, a quick way to do this count, as I mentioned earlier, is to go, you have octet here, and then 2, 4, 6, so 6 plus 8, that's 14. Okay, we only have 10. That means we need to do more sharing, and so if you remember what we did last time, if you don't have enough electrons to go around, you need to do more sharing. You look at neighboring atoms, take out a lone pair from each of the neighboring atoms. Take this lone pair out, take that lone pair out, and replace that with a bonding. That reduces 14 to 12. Okay, you still have the wrong number of valence electrons shown. So if you want to go down to 10 from 12, you take another pair of lone pairs out from neighboring atoms and replace it with a bonding pair. And so here you have, okay, 2 plus 6 plus 2, that gives you 10 valence electrons. So this would be the Lewis structure for HCN. But you can also connect the hydrogen to the nitrogen instead of the carbon. So if I have I can put my hydrogen over here, and I have my lone pair on my carbon. So if you work that out, you'll see that this is also a valid Lewis structure. This, in fact, H and C, is also known as hydrogen isocyanide. Okay, so this is hydrogen cyanide. This one over here on the right is hydrogen isocyanide. So we say these two are different isomers. They're different molecules. Okay, so they represent different compounds. What if I drew something like this? Let's say I have H and triple bond C and a lone pair on the carbon. Well, if you look at this closely, this one and that one. In both cases, hydrogen is singly bonded to a nitrogen, and then the nitrogen has a triple bond to a carbon, and a carbon has a lone pair. So these two, it's just like I flip this thing around, right? So these two are really just the same. So they're not isomers of each other. So you can say they're the same isomer, okay? But these two over here would be different isomers, okay? Different. So like if I wrote this one this way, I can rewrite this one with the nitrogen on the left, carbon in the middle, hydrogen on the left. Since carbon is in the middle in either case, these two would be the same. Okay? One more note. What if we have something like H, C, H, H, and H, H? This is called methylamine. You don't have to remember this name. But you can see this is hydrogen, carbon, and nitrogen. Now this is a totally different molecule. This is not even an isomer because for two things to be considered isomers, they have to have the same number of atoms of each kind. All right, just for clarification.